Good morning, guys. This is Go Math. Yay, 9.1. So we're starting chapter 9. I hope some of you took a look at chapter 8 and did the videos and the share and show just for some extra enrichment and practice. That was the last chapter for fractions. Although we're still going to continue to work with fractions, we're just going to use them in a different way in this chapter. And chapter 9, I believe, is called Patterns and Graphing. So, excuse me, it is a lot about graphs and data. So your essential question for this lesson is, how can a line plot help you find an average with data given in fractions? The first problem is students have measured different amounts of water into beakers for an experiment. The amount of water in each beaker is listed below, and we have all these quarter cups, half cups, 3/4 cups here. So like each beaker that they filled had this amount in it. So they filled how many beakers? 1, 2, 3, 4, 5, 6, 12 beakers. If the total amount of water stayed the same, what would be the average amount of water in the beaker? Okay, so the average is, when we think about data, the average is when you add them all up and then you divide by the amount of data you collected. So it's, another word for that is mean, if you remember that from 4th grade math. So let's see how they ask us to do it in this one, because it doesn't look like we're adding any fractions here. It looks like we're going to use a line plot to figure it out. Count the number of cups for each amount. Draw an X for the number of times each amount is recorded to complete the line plot. So what they're asking us to do is figure out how many 1/4 we have. So how many 1/4 are here? 1, 2, 3, 4, 5, 6, 7. So for 1/4 we have 7. And then for 1/2 we have 1, 2. And then for 3/4 we have 3. So we crossed the drawn X for all of those that we counted. And then we also put them over here on our line plot. So we have how many exit or how many fourths? They already have 4 there for us for some reason. So we have 7 there, 2, and 3. Okay. Step 2, find the total amount of water in all of the beakers that contain 1/4 cup of water. There are 7 beakers with 1/4 cup of water. So there are 7/4, or 7/4 is equivalent to 1 3/4 cups. Find the total amount of water in all of the beakers that contain 1/2 cup water. There are 2 beakers with 1/2 cup water, so there are 2 halves, or 2 halves, which is equivalent to 1 cup. Step 4, find the total amount of water in the beakers that contain 3/4 cups water. So we have 3 here, so 3 times 3/4 is 9/4, or 1 and, oh, sorry, not 1, 2 and 1/4. So instead of adding them all up and dividing by 12, we went ahead and used our multiplication of fractions to kind of make our steps a little bit easier. And we multiplied however many 1/4 we had, however many 1/2 we had, and how many 3/4 we had. Then we're going to add them all together. So add to find the total amount of water in all the beakers. So 1 3/4 plus 1 plus 2 and 1/4. Well, that's 1 plus 1 plus 2 is 4. And 2/4 plus 1/4 is 4/4, or a total of 5 cups of water. Divide the sum you found in step 5. So this is the total amount of water we have. We want to find the average, so we're dividing by the number of beakers we filled, which was 12. So 5 divided by 12 is 5/12. So the average amount of water, which is pretty close to 1/2, the average amount of water is 5/12. All right, what's next? Try this. You can use the order of operations to find the average. Solve the problem as a series of expressions that use parentheses and brackets to separate them. Perform operations from the inside of the parentheses to the outer brackets. Ooh, look at that fun equation there. Now that may look complicated, but when you look at it or pull it apart, it's exactly what you just did. 7 times 1/4, 2 times 1/2, 3 times 3/4, and then you're gonna do those parts first, then add them all together, then divide by 12. So this one is 7/4 plus 1 plus, what was that, 9/4 divided by 12. And so when we add those together, 7 plus 9 is 16 over 4, which is 4 plus 1 is 5. Divided by 12 is 5/12. That was fun. Okay, let's look at this example. Rain divides 3 2-ounce bags of rice into smaller bags. The first bag is divided into bags weighing 1/6 ounce each. The second bag is divided into bags weighing 1/3 ounce each. And the third bag is divided into bags weighing 1/2 ounce each. Find the number of 1/6, 1/3, and 1/2 ounce rice bags. Then graph the results on the line plot. Write a title for your line plot. It should describe what you are counting. All right, so what are we counting? Number of bags of rice, right? Is that what it is? Weight of bags of rice. Weight of bags of rice. And what unit of measurement are we using? Ounces. All right, that was step 1. Step 2, label 1/6, 1/3, and 1/2 on the line. That's already done for us to show the different amounts into which the 3 2-ounce bags of rice are divided. Got it. Use division to find the number of 2-ounce bags, 3-ounce bags, and 1/6-ounce bags, 1/3 ounce bags, and 1/2 ounce bags that are made from the 3 original 2-ounce bags of rice. So she divided them equally, right? So we're dividing the 2 bags of rice by 1/6. So to divide a whole number by a fraction, we're gonna flip this fraction into its reciprocal. So 1/6 written as a reciprocal is just 6. So 2 times 6 equals 12. We'll flip this into its reciprocal, which is 3. So 2 times 3 is 6. Flip 1/2 into its reciprocal, which is 2. And 2 times 2 is 4. Draw an X above 1/6, 1/3, and 1/12 to show the number of rice bags. So that was an interesting way of doing it. So if I took 2-ounce bags, or if I had 3 2-ounce bags of rice, those 2 ounces can be divided by 1/6 12 times. So I put 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 X's above 1/6. And then my 2-ounce bags divided by 1/3, I would have 6 bags if I divided it by 1/3. 4, 5, 6. And if I had my 2-ounce bags and I put a half, or I divided them by 1/2 ounce, I would have 4. All right, so we did that step, we did that step. That's interesting. All right, so the work you guys are gonna do on your own is pretty similar to what you just did. I'll go through this first one with you. Use the data to complete the line plot, then answer the questions. Liliana needs to buy beads for a necklace. The beads are sold by mass, which means a lot. And she sketches the design to determine what beads are needed. And then she writes down their sizes. The sizes are shown. So this G means grams, which is a metric unit of measurement for weight. So this is what she needs: 2/5 grams, 2/5 grams, 4/5 grams, 2/5 grams, 1/5 gram, 1/5 gram, 3/5 grams, 4/5 grams, 1/5 gram, 2/5 grams, 3/5 grams, 3/5 grams, 3 fish, 2/5 grams. What is the combined mass of beads with the mass of 1/5 gram? Think there are, so we've got to then take these and put them on our line plot, okay? That's our first step. So 1/5, we have already 3 here. 1, 2, 3. Oh, she got it done. So it looks like I'm gonna just not continue on with the rest of this. You obviously can, but to answer this question, all I need to do is work with 1/5. So it's just to make things simpler for myself and not give myself more work than I need, I'm just gonna work with that. So there are 3 X's above 1/5 on the line plot. So the combined mass of beads is 3/5 or 3/5 grams. What is the combined mass of all the beads with the mass of 2/5? So now this is where I got to go back in and find my 2/5. There's 1, 2, 3, 4. 1, 2, 3, 4. So 2/5 times 4 equals 8/5 or 1 3/5 grams. What is the combined mass of all the beads of the necklace? So what do we do here? We add them all up. So I already know that I have 3/5 for this one. I know for 2/5 it's 1 3/5. And then now I'm going to move on to 3/5. There's 1, 2. So 2 times 3/5 is 9/5. Right? No, sorry, 6/5. And then, oh wait, was there one more? 1, 2, 3. I was right. It's 9/5. 9/5. And then there is, oh, did we miss a 2/5 too? 1, 2, 3, 4. Uh-oh. Oh no, we got 4. 1, 2, 3, 4, 5. Goodness. 2/5 times 5 equals 10/5, which equals 2. So this is actually 2 grams. Wow. Okay, then we've got 4/5, which it looks like there's 1, 2. And so 2/5 or 4/5 times 2 is 8/5. So we add those all together. 3 plus 9 is 12, plus 8 is 20/5, which equals 4, plus 2 equals 6 grams. And what is the average mass of beads of the necklace? So we take the total grams that we added, or the total weight, 6 grams, and we divide that by however many beads on the necklace that we added up here. So we've got, there was 2 here, right? So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6 divided by 12 equals 6/12 or 1/2 grams. So the average mass of beads on the necklace is 1/2 grams. That was fun. All right, use the data to complete the line plot. Then answer the questions. A breakfast chef used different amounts of milk when making pancakes. Depending on the number of pancakes ordered, the results were shown. So like if Pete ordered a certain amount of pancakes, the chef used 1/2 cup of milk. And then his sister Sally ordered a smaller amount of pancakes, and so the chef only used 1/4 cup milk. So these are all the measurements of milk he used throughout the morning to make pancakes. So it looks like you're gonna need to plot those on your line plot and then answer these questions based on the information here, okay? So I will go ahead and fill out these answers and complete this and post the answers to both the front and the back of 9.1 Share and Show underneath the video. So go ahead and complete the rest of this on your own and then come back to the PDF that I'll post to check your answers.